So I'm giving the link. That data set, you have to go there and go to the data card. Okay, and the thing you have to do is you have to download this data set, all of it. I think that is the only way you can get the data, and you should have this three folders. Other folders you can delete. So we need these three folders as of now. So we'll do potato classification. So potato has three kind of images. One is early bright, is a disease name. Late blight is also disease name, and another is healthy. So the photos of that is given. Images are given. We can, I guess we can see that. So this is early bright. That is how the images of that looks like. Another is late blight, like this. Okay. Third is healthy, right? So this is a healthy leaf. So these are potato leaf images, not potato images. So when we grow the potato is underground. Leaves come out. So from that leaf, we have to identify that are there any disease in the potato. Okay. So I've given you the data also. So in this workshop thing, the data is there. If you open this data or you download the data in a zip format, you'll see there are three folders only available, and this is small data. If you don't want to download the whole thing, you can go with this. Okay. Now, as of now, I'm not connecting it to the drive. I can connect to the drive and then load the zip file and all. I can do that. Another thing is I'll just upload it. So I think that will be faster as of now. So I'll just upload this thing. Okay. I guess it will take more time. Let's not do that. Let me connect drive only. So I'll write I'll let this to connect the drive. I'll connect it. Was unsuccessful. So my drive is mounted. It's here. Now I have to go to my drive. Sure, where is it? Here, right? So this is the path of it. So I'll just copy the path. Call it as path. Okay. And what I have to do is I have to unzip it. Okay. So that unzipping I'll do using this import zip file OS. So here I have to click the zip path. Okay. And yeah, that's all. So with this I can extract it. So you can see the potato data is here. It has this folder. In this, the three folders are there. So each folder contains each of the class of the potato leaf images. Okay. So when we do image classification or something like that. The thing that the data you are going to get is in this folders. Okay, so make sure that the folders, or whenever you collect the data, that you keep different classes in different folder. That's how it works. Like if you keep all of the images in one folder, then there is no way um, to classify that which is what, right? So you have to keep it in different folders, separate folders. So this is one class, this another class, like that. Okay, so that's what is here. So as of now, we'll load it. The general idea is that you should do train test bit also before that. So we don't have here that way. Otherwise, the data you get is like, or you how you collect or how you keep is you keep a train set with these three classes, and test set of these three classes. That is the ideal way to keep the data before starting your work. Okay, but we don't have that way. That is okay. So this kind of issues might happen, and then what should we do? We'll see that. Okay. So what I will do is I will uh, I'll first import few things. We have done that before also. These are libraries. One is torch optim data set. Uh, twice. But data loader, random split to so we'll use random split to split it and train and test, and rest of them, transforms is what we'll see in a minute. Data set, I'm not sure if it will come. I'll show it. Okay. So few of the things I'm importing, and okay. So that is what importation is. Now what I have to do is I have to import this thing from a folder, right? So I have to write data sets dot image folder. So I think it should be folder image or image folder. Yeah, image folder. Okay. And then in this you have to give the path, right? So the path I'm going to give is this one, which has 3 more folders. Okay, so this path I have to give. I can say it as something like directory or something where it is. So I'll give the directory to it, and while doing it, I wanted to do is transform. So if I don't do anything, let's not do anything before. Like I'll show you the importance of transform for that, and I have to store it in let's say something I have to call, let's say full data. Okay, that's what I'm calling it, full data set. Now if I show you full data set, length of it, that means like how many images are there. So we have total 2152 images. So as of now, I recall that 1000 are early byte, 1000 are late byte, and 152 are healthy images we have. Okay.
So does it all does it always detect the contents of the subfolders, or like do we have to follow some naming nomenclature, we have
so
to name the folders in a specific way?
yes, correct. Because if you see classes, if I run this, so the classes name it got using the folder name. So the naming is okay, but it will give 0, 1, 2 later on, the indexing. But from this only, it gets to know that there are 3 classes available, and I have to do multi-class and not like binary classification, something like that. Okay. So here, from here, we'll get to know that, or later on, what we'll do, we'll get to know that.
Okay, so like the folder name can be anything, and it will take the name of the class as the name of that folder, right?
Yes, it could be anything, but you just have to be careful that the different images should be in different folders. That's all. That's all you have to
All
be
right, for different
careful.
classes. All right.
Yeah, correct.
All
Okay. Now, if I show you, let's say, what is it giving? So it is giving us a PIL image. So how does it work? Is PIL is like Python some image like uh, that is Python imaging library, right? Something like that. It's there. Uh, so so what does it give? Is it gives two things. One is image and zero because I didn't transform it. Okay, that's why I'm getting two things. One is image and one is label. So it has labeled it as zero. So zero is zero. If you see, if I write, let's say 1200, do that. For that, you can see class one, and I if I do it more than 2000, let's say 2100, that is there. So that is class two. Okay. So 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 as of now, it has concatenate all of them one after another, and that's how the classification. It has given the numerical code to the class. Okay. Now, what we wanted to do is we should uh, look at like what is image and the label. That's how it is giving me. So if I show you the image of it, this is the image and this is a label. Okay. So our the issue is, as of now, I'm taking as images, right? But I should transform them into numbers. So how do I do that? So a transform module exists in torch vision. It gives the access that we can easily convert it to tensors. So what I have to do is I have to write transforms. What I should do is I'll do the same thing again here, but this time I'm going to change it to this side. So transforms dot to tensor, yeah, to tensor this way. Okay, so that's what we have to do. If I do that, now I'm taking again full data set. So if I do this part, and let's say image. So you can see this time it's a tensor. Okay. You can see the shape of it, image dot shape, and that is 3 cross 256 or 250. So in this, it is like first it is showing depth, then width and height, and height.
Depth is actually one
RGB.
layer for red and one for green and one for blue, right?
So that is correct. So this is RGB. Okay, red,
Okay.
green, blue. As of now, 3 channels are there. So this 3 is coming up.
And this is just a single image, not a batch, right?
No. As of now, just single image.
All right.
Yeah. So that's what it is. Now, the next thing we have to do is we have to do train test split. Okay. So that's what we'll do. We will do the train test split. So for that, I'll use this random split. Um, so random split. I have to give my full data set.
Sorry,
And
can we do this by using SQL also?
uh, we can't do that
Since it is
because
deep learning, we can't do that using
no.
SQL.
So let's say I'm not sure if we can do it or not because uh, it could work. We could work. I'm not sure from. Okay, no. Uh, I'm not against it, but let's say if I do full data set, and I give test size something. So if it doesn't work, I won't spend time on debugging it, but I'm just trying it. Okay. So random state equal to something, and I want train set comma test set something like this. Yeah, it works. There is no issue with it. It just I have to. I'm not sure how will I divide this into x and y later on, since each of them are a tuple, right? So tuple contains two things. One is image data and another is label.
Yeah,
So
I think you could add a separate variable for containing the labels, and I think you'll be able to separate it that way. If this works, then that is really nice, I think.
yeah, so you can try it later on, but as of now, I'll do it the way I was planning to do.
Sure.
Okay, sir.
So let's say I use some numbers I have to give, whichever I choose. So one thing you can do is you can write, like, let's say, length of my full data set, right? That is this one. And you can write like 80% of that I'll take, and you should make it as integer. Okay, so this number you can choose here, and the good idea is that what you should do is uh, minus this one. Okay, just so you don't go out of the bound, something like this. So you can maybe give it a variable name, let's say train size or something like that, and this is test size. Okay, and give train size here and give test size. Okay, so this will give you the sizes of it that I have to store in another variable. Okay, um, so what does this random split do is it will give you the indexes of it. As of now, we are just collecting indexes. The reason is we'll use data loader for retrieving that indexes. Okay, so if you're not aware, but in data loader, if I give this train size or a train whatever the indexes I'm going to get from this, then it will give me the array to it, right? So that is the idea I'm doing it. Okay, so what I'll do is I'll call it train set and test set. Train set, something. Uh, don't worry, like just know that this will help us in dividing the data. That's all. Now what you have to do is you have to use the data loader and give this data loader, give this train set to it, which has both, right, like x and y pairs, which we just now see here in this one, that in train loader, when I create a train loader, I give the x and y both together. Okay, so here also I'm giving that thing. So random split will do that splitting, and now it will give that here. And I want batch size of 32, shuffle equal to 2, and I'll call this as train loader. I'll use the same name. Okay. Like this, and similar thing I have to do for the test loader, shuffle equal to false, and batch size same thing, nothing changes. Okay, so I got my data this way. So this thing I'll use for the batching, right? Now I'll explain the model part. And for modeling purpose, what I have done is I already written the code, just so you know it's a little bit easy to explain. I will show it here. Okay. So what you have to do is, if you want to do convolution 2D, so just remember that when we do convolution 2D, the kernel depth of the kernel is same as the depth of the image. So in this case, our image have depth of 3. So kernel also will have depth of 3. Okay. So that is there. Now this images, right? This images have dimension of 256 cross 256. So if you see it in the, when you download the image, and you can check the image dimension by properties or something, like in computer it has. From there it will show you that it is 256 cross 256 image. Okay, so that's why I I I'm taking that as a image size, input size. Okay, now this is a convolution layer. Okay. Now and after that we are applying ReLU, and then doing max pooling, and then again applying convolution, again applying ReLU, another max pooling. Then after that, this part, right? So this is one convolution part. Then we flatten it, right? That's what we do. So I'll show you one CNN architecture. CNN architecture, for example, yeah, this will. Okay, this is a little better. Okay, so you can see this is a architecture of CNN. So initial 256 cross 256 cross 3 is the image size. Then we apply convolution and get output. Okay. Then we apply pooling layer, then get output. Then we apply another convolution pooling layer. Then we flatten it. So this flattening is here, and then another layer we can use for the output computation, right? So this thing, how, so now what I'm calling is this part, which you can see here, which is fully connected. We call this as classifier part, because it does the classification job. Initial part is for feature extraction. Okay, so this whatever we do in convolution, we generally have the idea that we wanted to extract the feature of the image. That's why we do the convolution operation. Okay, so that's what I have mentioned is convolution, but you can mention feature or something. And then another is classifier. Okay, uh, so the sequential, inside this I'm writing all of them. Now I'll show you the how I'm writing all these internal things. So I'll show you that what you have to do is say nn dot convo on 2D, right? So 2D means the depth is same as this. I have to write input channels. So channels means I have to give the depth of it. So this is a 3 channel image RGB. That's why I'm writing 3. Out channel, you can choose whatever you wish. You can have it, right? So this is the number of filters you are applying. Okay, number of filter, remember. Then you have to define what is kernel size. Kernel size is 3 cross 3 or anything. Then you have to decide what is padding, right? So let's say padding equal to 1, 2, 0, anything is okay. Something you have to, one more thing you have to decide is what is the stride of the convolution. Okay, so this whole thing, if you define, then this is a convolution layer. Now, how do we decide the next layer after this, right? So nn.relu is okay. This is just the activation on this. So that part is okay. Uh, we don't change anything here. Now let's say if I wanted to apply another convolution or max pooling after this. Let's say max pooling again, padding stride. For max pooling, we don't need to define channels because the pooling layer have similar same channels what it has in the previous convolution layer. Okay, so channel won't change in the max pooling. Listen, now again I wanted to apply another convolution. This much from then say padding equal to whatever 1, stride equal to 1. Okay. Now, so let's say we initiated with 256 to cross 256 image, right? So due to kernel size, I have to reduce the 3. So now I have to compute the dimension of my output, right? What kind of dimension I'm going to get, and due to padding, I'll add 2 to it. Okay, and there is stride of 1, so I'll divide that by 1, whatever my value is. So the whole thing I'll add 1 to it. So division by 1 is nothing, like it will not affect at all. So addition of 1 will happen, and you can see the output I'm getting is 256, right? So I applied a convolution on 256 of this type, and I got 256 out. Now I'm applying a max pooling, and in max pooling I have 256 input. Kernel size is 2, so I'll reduce that. There is no padding, so I won't add anything. Stride of 2 is there, so I have to divide it by 2, right? So the whole thing I have to divide by 2, and then finally addition of 1. So this computation of the output shape, if you can refer the deep learning week 8, in that it is being explained that how to do it. As of now, I'm just going through it. Then this will give you 256 minus 2 is 254 by 2 is going to be 254 divided by 2, 127, and plus 1, which is 128. So that is what the output you will get here. Then on 128, you are again applying a 64 channel thing. So here you have to give 32, because you are going to get 32 channel from here, right? So this 32 channel now are going to be input channels, and 64 you are you want out. So that's what you have mentioned here. You can change this out channel how many you want, but in channels you can't change. You whatever is there in the previous whatever called image or anything, that you have to use. Okay, padding, stride, kernel size, that is all variable. You can define by yourself. There's no issue. Now here it will be like 128 minus 128 minus 3, a padding of 1 and stride 1. So again it will give me 128 as output. Okay. Now on that I'm applying ReLU and max pooling. Okay. The ReLU won't change anything. It's just an activation function. So there is no change there. Now here if you see 128 kernel minus 2 I have to do, divide by 2 for the stride, addition of 1, that will give me 64. So 64, so last layer or last of this feature layer, convolution part, this convolution part. So this last will be will have 64 depth, because I have mentioned 64 as out channel here. That's why 64 of depth, 64 of width, 64 of height. So all of them are 64. Width, height, depth, all of them are 64. So that's why I have to use that that many. If I do the flattening, I'm going to get this many features. So this thing you have to actually calculate. Like if you could not able to calculate this part, then you won't be able to write this one. Okay. So if you don't able to, then the next part is not possible. Another way is like you go for it, you run it, it will show you some error that this much multiplication of dimension is not possible, and you can take a hint from that my whatever this computation is incorrect, and you can use that. Okay. For example, what I mean is, let's say I write 61, right? So this is incorrect calculation. Where did I miss? Kernels. Okay, shit. This one. This should be commented out, and this is in comments. This one. Okay, so this is what my model is. So you can see that that's what I did. One sequential I created for the feature part, and one is for classifier part, and then you can see I'm doing self convolution. I'm calling that, giving x to it. So convolution means I am calling this one. If you don't like this, I will call it features. And then self dot features is what I have to call here. I have to give x to it. Okay, and I'm storing it again in x. So that same x I'll give here, and same dot self dot classifier I'll call, and again I'll store it in x and return the x. Okay, it's the same as this. There's nothing I'm doing different. It just looks different. That forward inside that I'm giving, I'm calling self dot network and giving the x to it. Okay. Same thing. So that's what we have done. So this is what class definition part. So now, is there anything you should do for it? Yeah, there's one thing I'll show you. This if you do this, it will give you the summary of it. The mistake is I should initiate this. Let's say my CNN. My CNN is there. 3 is the input. Type should be same. No idea where this is coming from, but that is okay. That is okay. So now what we'll do is we'll define the model, or let me take this part which we did earlier, right? So this much, this I'm expecting that you are kind of understood this part. So I'll take the whole thing here, because nothing of this going to get changed. Okay. So we have this part now. Torch.menu seed, that is okay. My model, I'm giving this, but instead of my model, I'll use my CNN, because that's what I named my class. So that's what I'll give. So I think there is a mistake here. I already kept it here. So let's see what it does. Extrain, then I have to give I don't have to give shape now, but instead of that, I have to give how many features you are going to get it. So that is three channels. So the number of channels, that's what I have to mention while initiating the model. And optimizer will use SGB. There's no issue with it. 30 epoch would be too much. It's a image data, so let's run for one epoch. If it works, we'll run for multiple epoch. If there is issue, we can manage easily. I'm turning on the training part. Epochs, loss per epoch. Okay. Feature dot labels in train dot loader, and something like this. So here is one new thing we are going to do is we are going to use device is equal to torch.device if CUDA is available, right? So I already showed you before that how we can move the model to, or how we can move the data to GPU, right? So that's what we are going to do. That when I get my data from train loader, so I'll do this features, move them to the device. So if you write this, it will move that to device. Now one more thing I have to do is I have to move my model also to the device. So I'll write model move to the device. Optimizers, we don't have to move it to the device. That is okay. Like we just need to do this. Loss function, there is nothing I have to change here. So this part is extrain. There is no such thing as extrain as of now. What I will so let's just print the total loss as of now. We'll see how we can do, because that extrain will not be there. So loss per epoch, right? That's what we wanted to print. So I'm not changing anything here. Let's see how does it go. Okay, so the issue is that this is what I was mentioning, that it was expecting 64 star 64 star 64, okay, 262144. But what we gave actually is we gave this one. So this was our mistake. It's being mentioned here. So from this idea, you might get an idea that I should not use this one, but I should use this part. Okay, so that if I write this one 262144, that is also okay. So multiplication is what I'm writing inside the model, right? I am writing 64 cross 64 cross 61. So if I make it 64, then there won't be any issue. So I should come here again and run it. Now there is some other issue. That is a size of tensor 32 must match a size of tensor B3. That is correct, because see, we are using a different kind of loss function. Like this will not work for classification. We have to use cross entropy. So that's what we'll do. Cross entropy loss. Okay. Now, does cross entropy loss supports this one? No, we don't have to squeeze now. Those predictions will come in 3-dimension. So not 3-dimension, but a vector of 3-dimension you'll get. So you'll get classes prediction probability values for all 3 of them. So we need all of them. So that's why I'm giving, and I am giving labels also for it, right? So I think I don't need to change anything here. It is expecting long here. So if that kind of error happens, what we can okay. So just in case, like give prediction first, then labels, then it will work. Okay. So you can see the first epoch has been completed. We have trained for the one epoch, and we got this loss. Now we can maybe run it for more than this. Okay, so you can see the loss is reducing. It's a cross entropy loss. Right. So and then the next part is you do the evaluation, right? So evaluation is same as this, what we just now saw, that we have to write model.eval here, and it will freeze the batch norm. So as of now, we didn't use any batch norm, but you can do that, try batch norm and all. But nonetheless, we will use model.eval for a practice. So there might be some other things also it will handle. So that is okay. We can, and then this part also doesn't change. So we will have that will have torch.nograd model.forward. So now this way we can't do it, since earlier we had x test as whole. Now x test is coming from this against another data loader. So what we can actually do is we can use this pipeline, like from here for feature labels in this, do model.forward, compute the loss, and submit. So there is going to be one epoch, so we don't have to write epoch there. and the loss. Okay, so this much I am taking here. I don't need any of this. Okay, so another thing, inside I am writing a loop. Instead of train, I would write test loader. The mistake. Test loader. Features, labels, forward pass, loss computation, and then finally I will print the loss. So this is for one batch. Maybe we can do is loss or total loss equal to 0. Plus equal to loss. Okay. So I guess we have done that. Here loss and the loss with cost of no grad. Okay, so this much loss I'm getting, cross entropy loss for this. A few more things you can do is thing you can try is how to find the accuracy score, how to find the recall score. So here the sklearn class and all won't work because sklearn expects that you give one class to it, then it will work. So either JQ, what you can do is you can. So let's say my y prediction, right, which I'm getting here. So how does it look like? So you can see it looks like this. Now I should predict the class of it. So what I can do is I can find the maximum value present here. I have to use some access. So let's see which one is, yeah, this one. If, so it is giving
Now,
me
could
like
you use softmax?
softmax. Why we didn't use softmax?
So like we had 3 classes, right?
Yes.
So I think softmax should work.
In what? Like softmax will work. So it is working now, but
Like the problem is classification, right? And
yes,
like we are doing multi-class classification.
yes.
So I think softmax should work because in softmax the output should be a vector containing the probabilities for each class, and whichever class the probability is high, I think it should work. The softmax, and then we could apply argmax over it, and then we could get the class index for the uh, for the particular class that the label has been assigned by the model.
Yeah, that is true. So, um, so actually, what happens is when we use cross entropy loss and cross entropy loss, internally it does apply the softmax by default. I'll show you that. So, create average reduce set softmax. Um, Notice that in case of equivalent applying log softmax or input. So if you read this, it does says that internally it will apply the softmax. Okay, so that is okay. So there would be some mistake with this part. What I will do is we can. So I have this on the code. I'll just run this part, and currently this is for the accuracy. Okay, so we are computing accuracy. What we are doing is what we are doing like features and labels. We are moving them to device. Outputs we are storing as model dot patches, or you can say model dot forward. Both way will work. Okay. Then torch dot max outputs 1. Right, so that's what we are doing. So if you see what is my what is my outputs? Outputs are like this. They're not summing up to 1. That is correct. So I can't directly give you the probability of it, but what I can say is, if the number is higher here, then it is going to be the class, right? So prediction, when we do the prediction, so it will not change the fact that the class is going to be 1 in this, and 0 in this, and 1 in this again, right? So that fact will stay there. So softmax internally inside the cross entropy, it is being applied, and while we do the prediction, we get some random, like it looks a little bit off, but when we do the class prediction, what we have to see is which is the highest one, right? Which has the highest value out of 3.
So like the output is already a tensor of a given shape and size, right? So like if we apply an element wise operation such as an activation function, maybe softmax or maybe argmax, then I think we could get the correct class distribution. Like all these scores will turn to
Yes, so
into
that's what we did. So we were finding the maximum, right? So it will be stored in the predicted one, and you can see if I show you that these are the classes being predicted for the images 1011. So these are for the last batch. So whatever is the last batch in test loader with respect to the 32 batch size, I can show you for that only, and we are actually doing for all of them, but we are not storing all the predictions. Okay? We care about the accuracy, and we are getting a good amount of accuracy. So this accuracy. So you can create another function like based on this, that how to score, how to use recall, or maybe you can use see if you have predicted value, and if you have the true labels, you can apply sklearn functions also. It will work. Okay. So you have to check it out, but it will work. That I can assure you. So that thing you have to you can explore. Now,
all right.
Another thing, I'll just put it here, just in case you want to do how you can draw the confusion matrix. So it's a little bit complicated code, but we can see whatever we are doing till now. That's what it is. Torch.max. It is storing in somewhere. Then some extra stuff is there, but this is how the confusion matrix looks like. Okay, we are using sklearn for that and using heat map to plot it. That's all we are doing for that. Okay. So these are the classes, and this much we have done the classification. I think we have a good model. That's what we have built. Okay. Now, what? So as of now, like I have completed my workshop content. Whatever I wanted to explain. If you have doubt, you can ask, or what I'll talk about a little bit is what you can do next. Okay. Anything? So one thing that we did different is this part. That's all. Nothing. I never changed anything in this, right? Except this loss function. All of the things are same. You can compare it. I'll have this. Of course, it's both the notebooks you have, this one and the previous one. When compare the code, there is nothing we are changing much. We are just changing one thing, is how the network is being initialized. Okay. So yeah, that's all I have for today's class. The next thing what you can do is, I have given you image. So I did it on potato. You can do it on maybe this bell pepper or tomato. So tomato has like more classes. You can try it on that. It will be little. It might become little difficult. I'm not sure, but you can try it out. That how does it work?